Hello and welcome to more nerdy rodent geekery video style transfer. Edit a single frame and watch those changes propagate through the entire video with the aid of a temporal deformation field. Yes, welcome to CoDef. Canonical content plus a temporal deformation field equals CoDef. Simply put, it's a little bit like Absinthe for short videos, but can achieve a slightly better consistency, just like the examples you can see on screen right now. It's free to use, and I'm going to go through how you can make these videos yourself. However, before I go through getting this set up and running on your home computer, it's probably worth noting you will need to set your nerd cap firmly to the on position, as there are quite a few steps and various text files to edit. This walkthrough will cover each of the steps, which includes installing the actual software here, installing segmentation tools for masking, optical flow processing, model training, and finally canonical image manipulation to produce the final video. It's also worth noting the software is pretty new, so do expect things to change in the future. Always check the GitHub page for the very latest information. As well as those geek levels of determination, you are also going to need a compatible environment. If you don't have the hardware, then there is a Google Colab available as well. How cool is that? Training time is fairly quick at around 15 minutes for a 4-second video, so even Colab free should be okay. Once trained, inference on a model is just a few seconds, so you can edit the canonical images as much as you like and see the results really quickly. For running it locally, you can see the requirements on screen there. They used Ubuntu 20.04, but I'm on 22.04 and that works fine. You'll need an nvidia GPU with at least 10 gig of RAM and around 20 gig of free disk space for all the models and your video files as well. It may work on Microsoft Windows, so feel free to test it there and let me know down in those comments. I suggest using something to manage your Python apps like Anaconda, Miniconda, or Mamba. These can all be downloaded for free and help avoid any dependency messes. Links are, as usual, down in that video description. Setup is fairly straightforward, though the package downloads can take a while. As mentioned, I'll be using Anaconda for these examples, so it's time to crack open that Anaconda terminal and create a new environment for CoDef. As you can see, you'll start off in Anaconda's base environment, which isn't where we want to install new stuff. We want a new empty house to play in and mess things around, so let's do that now. There it is, conda create --name CoDef. Obviously, I have already created mine, so I'm going to say no there, but you would say yes. Once your environment has been created, you can just go ahead and activate it, conda activate, whatever you called it, and there you go, it's changed from base to CoDef. With your fresh Python 3.10 environment ready to go, it's time to download the software from GitHub. Navigate to wherever you want to download your GitHub stuff to. I download my stuff to GitHub and we're going to run the git clone command. Now at the top here, you can get everything you need by going there, selecting copy and paste. There you go, it's copied it. So now when I do git clone and paste, we will have the URL we need. Once again, I have already downloaded this as it says on screen. While Git typically comes installed as default, in case you haven't got it, maybe you get an error message about command not found when you try and do Git, then you can just do apt install Git. You'll also want ffmpeg as well, so once again, if you don't have that installed, just run sudo apt install ffmpeg. Right, so with all that software downloaded, you can cd into the CoDef directory. For this software, it's best to use NVIDIA CUDA 11.8. So I am using Anaconda to install that there with conda install pytorch, torchvision, torchaudio, and pytorch equals 11.8. That'll take a little while to just go through and install. And if you're wondering where these installation commands come from, it's just the PyTorch website there, stable Linux Python CUDA 11.8. Once you've installed PyTorch, you'll also want to go ahead and install cuda-nvcc and also the cuda-toolkit. You can then install the rest of the requirements with pip install -r After which you'll also install tiny cuda-nvcc, which you can copy and paste the command from their GitHub page, and that will go ahead and install that as well. And that's it. You've got the main program installed, although we will have to install something else in just a minute. So it's video time now, but there are a couple of things to watch out for here. Firstly, only short videos are supported. One of the longest example videos is 120 frames. Like with Ebsynth, fast motion videos may not produce the best results either. You may want to download the example video data. They've got some there and there. That's two different archives, and that's about 9 gig unzipped. So make sure you've got plenty of space for those. If you want to train your own custom video, all you need to do is extract the video frames, but you can also optionally generate masks and optionally generate optical flow files too. Now, the first thing to do is extract your video into frames. Let's have a look at the directory structure they've got. So they give you the directory structure here, CoDef, all sequences, name 1, name 2, whatever you want. I've already downloaded those example videos, so there's lots in there. And I've also created my own one called Nerdy, just so you can see what it's like to create a completely custom one. So there it is, under all sequences, you've got all your different videos. And then the first one there, Nerdy. So you repeat the name like they've got in here, Batman, and this contains your original video. So there are all the frames, just so we can have a quick look at the frames there. That's just a split out of this video I downloaded from Pixabay, just a flower with a slight bit of motion wobbling in the wind there. If you're using ffmpeg to create those video frames from your video, then it's a good idea to make a directory to put them all into. There we go. We've made one. And now I've got an input video here. So we'll just have a quick look at that. There's my input video. As shown, it's just those flowers going in the wind. And what I can do is just run ffmpeg there. So I'm running it at a rate of 25. Input video there, starting at number 0, using the pixel format RGB24 and all sequences Nerdy. And I'm making it 5 characters long for the name. That's useful because in a minute we're going to use segment and track anything, and that uses exactly the same format. So there we go. We got the 5 digits, .png, all frames from that video. Next up, I'm going to generate this masks directory here. So this is the output of the mask from segment anything. There we can see it's moving, and there's also some processing scripts we're going to run which will create this mask 0 and mask 1 directory. Now these are fairly straightforward. As you can see, it's basically just a black and white mask. So that's the foreground, and then masks 1 is the background, which is essentially the inverse. While you can create those mask files using anything you like, they used segment and track anything, so that's what I'm going to do as well. Being a different app, same deal as before, make a new environment for it using Anaconda. I've already created it, activated it there, and then you will need to do exactly the same as before. So you'll conda install PyTorch, follow all the other commands on the screen, download with a git clone and cd into your segment and track anything directory. Then they have an installer, so you can just run that. Again, this will take a few minutes to run through, possible cup of tea time. You'll be having a few of those with all these installation scripts. But this one's a bit weird because it will actually sort of fail. Now, we can see what will happen locally by having a look at this collab as well. So there, once you've git cloned it, you've downloaded it, you're running the install script, it will go through, it'll look like it's working, and then you'll get this error here. This isn't too bad because this is actually a really old program. For some reason, they're trying to pip install zip, which is from about 10 years ago, and this thing fails because it's for Python 2. However, they ignore the error, and the very next command they run is the download checkpoints, and then they reinstall Gradio, which is where the install script fails because of that. So pip install Gradio, zip fails because it's such an old program. G down and ffmpeg we've already got, so we'll actually uninstall that later on, but all you really need is Gradio and G down. So once you've run that install script, you'll see that failure message. It's absolutely fine, just completely ignore it, and pip install gradio and G down. Now, the very first time you run this, you'll also have to download some checkpoints as well. So if you make the checkpoint directory, obviously, once again, in my case, it exists already, and then just run the download checkpoint script, and that will download 3 models for you. If we go and have a look at that directory there, and we can see the 3 model files there. So that's what you should have in your checkpoints directory. Okay, so with the install run and the download checkpoint script run, you are then ready to run the Python Web UI app. So let's just get rid of that download because I've already run it, and we'll just run the Python app. There you have it, segment and track anything. So just drop your video into that first one there. So we've got input video, that'll give you the thing down the bottom. Now you can segment everything if you want, but I just want these leaves. So let's have that bit there. And there we go. We've got a nice segment just with the flower head. Once you're done, you're ready to go. Just hit start tracking, and that will go through and create all of the mask files for you. So there it is. We've got the final video with the track and the segmentation put on the video, but we don't want that. We just want these input masks here. So they're just that sort of pinkish frame. Take this input masks directory, we'll copy that, then go over to your CoDef where you've got your video. So mine is called Nerdy. Paste that into there and you've got input masks. Now this actually needs to be called Nerdy Masks, so you can just rename that. Obviously I've done that already with the Nerdy Masks directory, so that's exactly what we got from Segment Anything. Okay, so now we've just done this first step here. Segment your video using Samtrack and put the mask files into that directory structure there. So whatever you've called your sequence name _masks. Next, we need to execute the following command. So there, cd data processing and python preprocess masks.py. If we have a quick look at this script over here, we will actually see this needs editing before we can run it, as it's just got a random root directory and the name there is beauty1. We'll be doing this a lot with all their scripts, basically copying them and then editing them. So I've got a duplicate there, which is my preprocess mask. So what I do is I take whatever their command is called and I just put my underscore. So whenever you see my underscore, it's their command. I've just copied it and edited it. So with my preprocess masks, I've set the root directory. So that's where I've got all sequences. That's that directory there. Yeah, that matches up. Okay. And name Nerdy. That's the name that I've called my sequences. So we've got all sequences, Nerdy. With those two the same, you can now run that script. It will process the masks and create these 2 directories. Okay, so let's do exactly as they say. CD into data processing. I've already copied my script and edited it, so it's got the right paths in it. I can then run that Python script and it will go through and create those 2 mask directories. So you should now have mask 0 and mask 1. Mask 0 foreground, mask 1 background. Excellent. So we've done this first part now of customize your data. Next, we want to extract the optical flows of the video. So we're going to use Raft and the data processing scripts they've got there. Once again, we're going to have to duplicate this script and edit it to meet our needs. So if we have a look at this, just to make that a little bit smaller. So in the Raft directory, you've got this run Raft, and the one I've got is my run Raft. Now, by default, it'll have a different name up the top there. So rather than edit this each time and change the name, I'm just passing in the first parameter there. So there you can see the original. There's mine. I'm just going to pass it in instead. In order to run my slightly customized script there, I'm just going to cd into the Raft directory. Now, the very first time you run this, you're also going to have to download some models so you can run the script there, models, download models. Of course, I've already run that, so I don't need to. Let's run this script now. So my run Raft, Nerdy, that will go through and create the optical flow files for me. Once again, this will take a few minutes. And with that finished, you've got your data preparation done. So if you've done all of those optional steps, you've done the masking and you've done the raft optical flow tracking as well, then you should have a whole load of directories. So you've got your original video, the new flows, and the 2 mask directories as well, meaning it is time to start training. Once again, you've got another script that you'll need to duplicate and edit. There it is, scripts train multi, and they've got a whole load of options in there. Now, you're also going to have to check the configs directory and make your own model config as well, which is where things got a little bit foggy for me, but well, you'll see what I mean in a second. So let's have a look over here. So we've got the configs directory, which has all of these different options in. If we take a look at lemon hit, for example, all of these are called base. So let's open this one up, which is why I say it's a little hazy. You've got some fairly obvious options like mask directory. You can set to null if you haven't got a mask directory, but then you've got the image width and height and the canonical width and height, and I've no idea why they're different. The image width and height is the size of the actual frame. So if we go and have a look at all sequences, lemon hit, and then in the lemon hit directory there, that's 960 by 540. So that's the size of all those frames. But why the canonical height and width is different, absolutely no idea. You've got learning rate and BG loss, other things like this sometimes changes between the config files. Occasionally there's an 8 in there as well, which you seem to need if you're using both masks and optical flow. As for what all those other settings are, I'm not sure how to change those. Number of steps is something that will happen later. So when you're training, it will always go to 10,000, regardless of what it says on the screen for the total number of epochs. Okay, so copy whichever one of those configs you want to. I copied lemon hit and edited it. And I also called it experiment 1 rather than base, just so that I know exactly what I'm changing. Here's the config file I'm using for this particular experiment. I've set image width and height and canonical width and height to be exactly the same size, the size of my frames, because as mentioned, I don't know what's going on. And I've also added the extra 8 in there. The training script, scripts train multi. If we go and have a look at that one. So we've got scripts down the bottom here. As you can see, I've duplicated a lot of these. So train multi, they've all got my underscore where I've edited them there. So my train multi, if we have a look at these, so there's the original one, train multi at the top and my train multi underneath. It's literally just the name and experiment name you want to change. All these are fine in this particular script. So once again, I've just basically changed it to accept input so I don't have to keep editing these every time. If you've made similar edits to your train multi script, all you have to do is run it like that. So there it is. Nerdy, that's the name of my frames from those all sequences things. All sequences, nerdy, that's how all those names match. And I'm calling it experiment 1. Now, this is the bit that takes about 15 minutes to run. So when you're doing this at home, once again, it's time to go and get another cup of tea. We're nearly there. We're almost getting to the fun part. Okay, so once training has completed, it's time to do a test reconstruction. Once again, you'll be copying that script, replacing all the things in it, and running it. So there it is, scripts, test multi. And as before, I've made the same changes just so I can pass in the name and experiment name. I've also changed the wait path as well to last.checkpoint. So if we go and have a look what's happened up here, we've got some checkpoints, all sequences, nerdy. This is finished training. It's got experiment 1, and the last one there is called last.checkpoint. Now, it seems like they might have renamed them. So scene 0.checkpoint is kind of what I was expecting, but for the most part, you'll find it says last.checkpoint whenever you train them yourself. The other thing is that somehow ffmpeg might have got installed in your conda environment by conda or by pip, and that may give some issues. So there, I'm uninstalling the version that conda gave me. So when I run ffmpeg, I can see it's the one that I've got installed in my local system. Okay, now I am ready to run that experiment. So let's run that test and see what comes out. Okay, that bit's pretty quick, only takes a few seconds, and we've got some results in our results directory, all sequences, nerdy, experiment 1. This is the one I've just done. So here it is recreating the original video, and that looks pretty close. Yep, I wouldn't have known that was a reconstruction. And even more importantly, the things you get in here right at the bottom are these 2 canonical files. You also get an MP4, so there you can see it in actual video format, but we get canonical 0, which looks a bit funny, but don't worry about that, and canonical 1. So this is the foreground and this is the background. Don't worry about the wibbles. That's absolutely fine. They all come out like that. Okay, so what do you do now? Well, after obtaining the canonical image through that previous step, you can now run that through on ControlNet, which basically means you can make any changes you want to the image file. You could just do it in a normal image editor if you wanted to change colors, draw things on there, but we're going to use ControlNet here just for a laugh. So I can say that's a painting. Here I'm using automatic 1111 for stable diffusion. I've got a canny ControlNet enabled down the bottom. Let's just make ControlNet more important. And you know, this is the creative part. So this is where you do whatever changes you want to this frame that you want to propagate through the rest of the video. So if you wanted it, you know, as a painting style flower, then you could do that. Maybe you wanted it anime style, entirely up to you. Style the frame however you like. Once you've got your canonical image in whatever style you want, you're going to need to put it back into that all sequences and whatever your thing is called _control. So mine's called experiment 1. So I've got nerdy experiment 1 _control, and there is canonical 0. So I've decided to make the flower this sort of purple color. Canonical 1 you'll still need as well. That's the background. So none of that will change. So we should just get the leaves in a funny purple color, and the middle of that, yeah, should be all red and a bit weird. Exactly like it says there, we have placed our image into all sequences, whatever your name is, whatever your experiment name is, _control. And yes, you've guessed it, we need to edit this test canonical script as well. So down here, close that down. Once again, in scripts, I've got test canonical and my test canonical. And of course, the changes we've already seen before. Last.checkpoint for the checkpoint name, and name and experiment name I'm just passing in. Okay, so let's go ahead and run that now. There it is. It's running my canonical image test. Again, this bit is quite quick. It does only take a few seconds to finish. There we go. Once we've got that finished, we can go back over to our results directory, crack that open, all sequences, nerdy, and then you'll see a new directory, experiment 1 _transformed, and that's where your new video is. You've got all the frames there and the dual output. Let's have a look at both of those together so we can see the original video and the flower video as well. There it is. That's not bad at all. That's not bad at all. Fairly consistent. We've got a little bit of edging around there, some strange lines, but that is a nicely transformed flower. There you go. That's content deformation fields for temporally consistent video processing. Little bit of work getting all the data up and running, but once it's all there, it is fairly quick to train and transfer. Hope you have a lot of fun with that, and perhaps with this next Nerdy Rodent video.